Hello and welcome back to Dr. Logic awkwardly does logic in her office. I'm going to redeem myself after my previous video where I didn't actually manage to give you a reduction of a formula into conjunctive normal form. I hate doing distributions of disjunctions over conjunctions under pressure. However, I have come up with a very simple example and it works and it only takes 5 steps and I'm going to give it to you to prove to you that yes, in fact, I can actually do it. Anyway, let me get up my whiteboard. There we are. And it's easy. So hopefully, rule of thumb, if you're ever having trouble with something, pick a simpler example. Having trouble with that one? Pick an even simpler example. Go back down to the very simplest example that you can and see if you can do it with that. So here we are. I'm going to take this formula, P or a Q implies R and S, and I'm going to reduce this into its conjunctive normal form. Now, this one, as you can see, not a tautology, not a contradiction. It's one of these. It's just merely consistent. Sometimes it's true, sometimes it's false. First step, change all of your implications into disjunctions. So that gets us not P or Q or R and S. So here we are. I'll just make a note over here. This is the get rid of implication steps. The next step is to look at all of your negations, and if there are any that are the negation of a complex formula, use De Morgan's laws and double negation to push them all into the atoms. So we've just got the one, but this one becomes not P and not Q. Or R and S, the other disjunction doesn't change. So this is an application of De Morgan's laws. Now we have a conjunction on this side and a disjunction as the main connective. So we are going to do the distribution of disjunction over conjunction. So I will again draw you kind of the schematic form that phi and psi or gamma is equivalent to phi or gamma and psi or gamma. So just so that you can follow along, not P is our phi, not Q is our psi, and R and S is our gamma. So we do the first distribution, and what we get is we get not P or R and S, and second distribution, not Q or R and S. But we can't stop here because this is not yet in conjunctive normal form, because as you can see, there is this conjunction that's inside this disjunction, which is inside the conjunction. That's too many embeddings. So let's do it one more time. We're going to do another distribution, except here, R is going to be our phi, S is going to be our psi, and not P is going to be our gamma. So this side of the conjunction, we get not P or R, and then we also get not P or S. Now, looking over here at the other conjunct, it's very similar. So R is going to be our phi again, S is going to be our psi, not Q is going to be our gamma, and so we get not Q or R and not Q or S. And look at that. That, my friend, is conjunctive normal form. We have a conjunction, so there's actually 4 of them, 4 conjuncts all forming together to make one formula. Each conjunct is itself a disjunction of atoms or negations of atoms, and that's exactly what we want. The only other thing that I'm going to point out is that in doing this step of distribution, so here, this is distribution, this is also distribution. So going from here to here, you'll notice that we very silently did an instance of commutativity. So in fact, what we have here is gamma or phi and psi. But you remember that order of disjuncts doesn't matter, so it's perfectly all right that we did that. You don't even need to make it explicit. It's something that just kind of gets folded into the application of the distribution. So there you have it, an actual successful example of a reduction from an arbitrary propositional formula into its conjunctive normal form. It fit on my whiteboard. It's wonderful. Please pause and celebrate with me, and then go off and try it yourself. See you next time. Cheers.